So we are relating it to real world problems, so things like area, how to set up these problems, and then continuing to solve with what we know about quadratic functions. So here are some videos about each type of problem that we're looking at. We're doing problems with area and consecutive integers. And then, of course, I'm recording, so that'll be uploaded here. That's where you'll find it. You picked up a worksheet. It's applications of quadratic functions, day 1. We'll finish the lesson on Monday, so we'll have a different practice on Monday. And then I said this yesterday, but I did extend the deadline for late work from the orange folders through Monday. So you have the weekend and Monday to get those assignments from the orange folders turned in, and make sure you get that taken care of. Any questions? All right, so problems relating to area can usually be solved using the quadratic equations. So starting with what is area? What's the formula for area? Length times width. Good. I usually go with the one that's base times height, but whatever you want to use, that's fine. They mean the same thing. So area equals length times width, or area equals base times height. Essentially one side times the other side, right? So if I told you, like in number 1, find the value of x if the area of the rectangle is 78 meters, well, I should be able to figure that out given what we know about area. All right, so since it says the area is 78 meters, I can replace that for the A, right? And then what is my length? X plus 7. And what is my width? X. So given that information from this diagram, I can figure out what x is. So looking at this, I need to multiply the right side out. How do I multiply that? What's that called? Good. It's the distributive property. So I'm just going to bring down the 78. What's x times x? And 7 times x. Plus 7x. And what you should notice is that when I did that, I get a quadratic function, right? Because that x squared is what makes it a quadratic function. So I can solve this a number of ways. I could factor, I could graph it, I can plug it into the quadratic equation. But what I'll do for this one is factoring. That was what we did last hour, and they seem to like that one the most. So let's try that out. If I want to factor it, or if I want to use the quadratic formula, I have to set it equal to what? To 0. So how can I make the 78 be 0? Good. If I subtract 78 from the left side, that's what gives me 0 there. But then whatever I do on one side, do it to the other side. So on the right side of the equal sign, are there any like terms anywhere? All right, no like terms. So we're basically just rewriting it. All right, from this step, and if we're solving by factoring, you could also use quadratic formula if you want. But if we're solving by factoring, that would cause me to set up my diamond. Remember, it's been a little while since we factored. Negative 78 on top, 7 on the bottom. And we need two numbers that multiply to the top but add to the bottom. So like I kind of just try out different numbers in my calculator. So like when I do 78 divided by 2. Question. Sorry. Yes. All right, so 2 times 39, would that in any sort of way be added or subtracted to give me 7? So it's not going to be 2 and 39. So keep looking for those factors. All right, 6 and 13. And which one has to be negative to make the diamond work? The 6. So double check it is negative 6 times 13, negative 78. All right, it is negative 6 plus 13, 7. All right, so we found our factors. So we have 0 equals x minus 6 times x plus 13. All right, for solving by factoring, remember we had to set each factor equal to 0. So it was x minus 6 equals 0 and x plus 13 equals 0. What's my first x value going to be? A positive 6. And what's my other x value going to be? Good. All right, so we solved for x and we have these two x values. Now, given that we're solving for like a problem related to area, would it make sense to have both a positive value and a negative value? Which one does not make sense? Good. I will never measure something, at least not for length and width, and get a negative number. So that minus 13 is negligible. We can kind of not use that one because that doesn't make sense for this problem. All right, so since we are being asked to solve for x, we know that x equals 6. Make sense? Any questions? And it equals 6 meters. All right, that's the unit that's being used in this problem. All right, does that make sense? All right. We're going to do another one together, or do you want to try it out on your own? All right, so then if you're taking notes on this one, finish up this one. We're going to look at number 4 next. All right, so looking at number 4. All right, we have the dimensions of a rectangle can be expressed as x plus 3 and x minus 8. So let's kind of draw this out, especially when they don't give us a diagram like in the other problems. It's probably helpful to draw it out. Zach, stop talking while I'm talking. All right, so what would the length be given the information in the problem? Which one are you looking at? Looking at number 4. Good. So the lengths of each side are given to us in the problem. We're just drawing it out so that it makes more sense to us. What else does it tell us in the problem that is helpful? It tells me that the area is 60. So given what we know that area is base times height. Well, since my area is 60, what's my base? What did we say it was? And then my height was Given this, now we can solve just like we did in the last one. All right, so multiply this out. How do I multiply it? What's that called? Distribute works. What's the other thing called? FOIL. All right, both of them work, but we'll do FOIL-y. So first terms, what's x times x? Outer terms, we have x times -8. Good, don't forget that negative sign. Inner terms, 3 times x. And last terms, we have 3 times -8. -24, and I kind of need to move everything, but 3 and -8 is -24. All right, all set equal to 0, or not to 0, equal to 60 from this step up here. Just bringing that down. Before I combine like terms, I'll do that all in the same step because I'm running out of room. What do I need to move before I can keep going? And I move it by, so subtract 60 from each side. On the left side, we have 0. On the right side, we need to combine some like terms. So does x squared have a like term? So I'm just going to copy that over. Do we have multiple x terms? So what are they? And when I combine them, I get close. -5x, and then we have -24 minus 60. What would that be? Good. All right, any confusion how we got here? All right, now I'm going to have you solve this. We can continue with factoring. We can set up our diamond with -84 on top and -5 on the bottom. All right, what are two numbers that multiply to -84? Good, and which one has to be negative to make that work? So 12 plus -7 gets me, good. So multiply them, they give me -84. Add them, we do get -5. And sorry, I'm out of room, so I'm going to copy this onto the next slide. All right, just know that we're doing number 4 right now. All right. So now, I don't know why these little boxes won't go away. Okay. Now we know what our factors are, yes? Yes. We have x minus 12 times x plus 7. And we need to set each factor to 0 and solve for the x's, right? So what is our first x value going to be? Good. When they're short like this, it's really easy to tell, but I'll still take you through the steps just in case. All right, but my first x value is 12. What is my second x value? Good. So x equals -7 and x equals 12. Since we're talking about area, which one is the negligible one, the one that we can eliminate? The -7 is the one that we don't use, right? So we're not going to use the -7. We're going to use the 12 because area, we can't measure a length of something and get a negative number. So before I just circle 12 and say that that's my answer, pay close attention to what the problem is asking. It is asking for the value of x, so 12 is our answer. X does equal 12. And this time it's inches. But what if the problem was asking for what are the lengths of the rectangle? Would the answer be 12 for that? No, because we know like these are the lengths. It's x plus 3 and x minus 7. Well, since we know that x is 12, how would I give you like an exact number for that? Good. So plug in that 12 for the x. So like we have over here, 12 plus 3, what's that? 15. So this side is 15 inches. And then the other side is 12 minus 8, right? Which is 4. So the other side is 4 inches. And that makes sense because when I do 15 times 4, I do get 60 for my area. All right, so what I'm saying is just pay close attention to what it is asking you. Don't just say, oh, x is 12 if it's asking for something different, like the width or the length. All right, makes sense? Any questions? All right, now there are some trickier problems on the notes and on your practice, but before I talk you to death about those, let's do some of the consecutive integer problems. All right, so any questions about the area problems? All right, we'll kind of break this up. We'll come back to the area problems and do like those trickier ones. So looking back at the note sheet, we're going to look at this side for the consecutive integer problems. Because in my last class, we saved it till the end, and I just feel like it confused them more than anything.
Sorry for the interruption. Hello, students. Just a reminder, next week there is AC Merit Writing Test for 10th graders. Yes, just 10th graders.
And who can give me an example of what consecutive integers are? All right, no, we've completely forgot. Yes? 1, 2, and 3. All right, 24, 25, 26, 19, 20, 21. So numbers that are next to each other are consecutive integers. All right, the formula for that, so like this would probably help you out.
One more reminder for seniors, you may pick up your cap and gown today from 10:30 to 12.
All right, so if like 1 was x, or n, I like using n for these. If 1 was n, then 2 would be n plus 1. And 3 would be n plus 2, right? It's going up by 1 each time. Does that make sense? How 2 is 1 plus 1, and 3 is 1 plus 2. Does that make sense? So make sure you're writing that in. That's for just regular consecutive integers. We also have consecutive odd or even integers. All right, those are a little bit different. Anyone know an example of consecutive odd even integers? 2, 4, 6, 8. So that's an example of consecutive even integers. Consecutive odd integers would be good. So for your examples, you could put those as your example, 2, 4, 6. Keep going, but I'll just leave it there. And then also we have 3, 5, and 7. So the formula for those, like if my first number is n, then the second number would be n plus 2. And the third number would be n plus 4. Because they're going up by 2 each time now. So like for the 2, 4, 6 example, 2 is n, 4 is 2 plus 2, 6 is 2 plus 4. Same with the 3, 5, 7. 5 is 3 plus 2, 7 is 3 plus 4. Make sense? All right, there's a reason we're going over them because you need that to set up your problems. So for problems like number 9, we have the product of 2 positive consecutive integers is 56. Find the integers. So what does product mean? What operation? Multiplication. So I'm basically multiplying 2 things together. We don't know what they are, but we do know that they equal what? 56. It tells us that in the problem. Now when I multiply these 2 numbers, it gives us 56. So it does tell us though that the numbers are going to be positive and they're going to be consecutive integers, meaning they're right next to each other. So if I'm using what I know about consecutive integers, if the first number, which is unknown, is x, what's the second number going to be? Close, not x plus 2, plus 1. Because they're just regular consecutive integers, not consecutive even or odd. Does that make sense? Everyone know where we're getting this from? The first number we don't know, so that's x. But since we know that they're consecutive integers, the second number has to be x plus 1. All right, and they multiply together to give you 56. All right, we're going to figure out the integers by solving for x. So how can I multiply these out? Good, so we're distributing the x to both numbers. So x times x is x squared. X times 1 is 1x equals 56. If I want to use quadratic functions to solve, how can I make that right side equal 0? Good. If I subtract 56 on both sides, now my new problem is this. X squared plus 1x minus 56 equals 0. All right, keep solving. We can do it by factoring again. So negative 56 on top, 1 on the bottom. What 2 numbers multiply to 56? And which one will have to be negative to make this work? Good. So multiply to give me negative 56, add to give me a positive 1. So we found our factors. All right, set each one equal to 0 and solve. So what's my first x value going to be? My second x value is negative 8. So I have 2 values. Now those aren't my 2 integers, right? Because they're not consecutive. They're not right next to each other. So which one is the one that I'm going to use that makes sense in this problem? The 7, and what tells you that? Good. We're looking for the 2 positive consecutive integers. So that -8 is negligible. We don't want to use it. Doesn't make sense in our problem. We're going to use this one. So one of our integers is 7, right? Because our first number was x, which is 7. What's my second number going to be? 8, because it's 7 plus 1. So if you want to like write your final answer, I would say 7 and 8. Question?
Yeah, so if we're able to do it by hand, do we show the work print?
There should still be some form of work. So if you get to like here and you don't show work after that, that's fine. But I would imagine that you have to have the problem set up and show this part before you get your final answer. All right, makes sense? Any other questions? Let's see if this also works in our graphing way. I haven't tested it out yet, but let me see. I don't see why it wouldn't work. But if I go to Desmos and I type in the equation where that black arrow is, I get exactly how it looks. All right, I do get a parabola. Maybe instead of having it equal 0, I'll just take that part out. So I typed in that quadratic equation, and I look for my x values. So remember we said that solutions are wherever it crosses the x-axis. Are those the same x values that we found when we did the actual work for it? -8 and 7? It is, right? And then which one do we eliminate because of common sense? Good. So that's another way too. And you can use the quadratic formula. That should get you the same x values, just whatever method works best for you. Any questions? All right. I kind of want to break this up a little bit, so I'll give you some problems to work on from your practice. So let me decide which ones. For the U-try on your practice, you'll do number 2. And number 9. All right, I know it's like evens or odds or whatever, but do 2 and 9. And we'll go over those ones and we'll break it up that way. So from your practice, those 2 problems.
Can I go to?
Yes. So dimensions of a rectangle are given by x plus 7 and x plus 2. So what does that mean? Well, it means the sides are represented by that. So let's kind of draw a picture to help us out. All right, so one side is x plus 7 and the other is x plus 2. The area is 66 square inches. So if we plug that into our formula for area equals base times height, that's where I get the x plus 7 times the x plus 2 equals 66. All right, that's the same thing that they have written here. All right, we FOIL it out. We get x squared plus 9x plus 14 equals 66. Then to solve using our quadratic equations, like our quadratic functions, we do have to set it equal to 0. So they subtracted 66 from each side, and now we are here. All right, from there, they decided to solve it by factoring. You could have also done graphing. What else? I don't know. But you could have done graphing or the quadratic formula. And essentially, we do that and we get negative 13 and 4. So they did their diamond method numbers that multiply to negative 52, that add to 9, are 13 and negative 4. Solve for their x's, and this is what they get. Why is the x equals negative 13 crossed out? Because it's negative, it doesn't make sense in context of this problem. So that doesn't mean for all problems we cross out the negative. Just for this one, if we're talking about area, we're not going to use that value. All right, we're going to use the x equals 4 to plug in to the problem. And they have that the answer is x equals 4, but what is the question actually asking? Good. So if it's what are the dimensions of the rectangle, I should have 2 values. I should have x plus 7, so 4 plus 7, what's that? 11. And then x plus 2, which is 4 plus 2, which is, so the dimensions are 6 inches by 11. 6 inches by 11. All right, so they didn't put that part correctly, but everything else is good. Questions about that one? All right, we're going to scroll down to number 9. All right, so the consecutive integer problem. We have the product of 2 consecutive integers is 32, so just like the one we just did. All right, they define the first integer as x, just like we did, and the second integer as x plus 1, because if they're consecutive integers, they're right next to each other. The only difference between them should be plus 1. All right, since it says product, what operation is that? When I take the product of something, I am multiplying, so that's what we did here. Distribute that x to both numbers. X times x is x squared, x times 1 is 1x. They also subtracted the 132 from each side to get this equal to 0 so they could keep solving. All right, again, we get here and we get a negative answer and a positive answer. Why did we cross out the negative answer? All right, because in the problem it says the consecutive integers are positive. If it says the consecutive integers are negative, then we would have used the negative value. But it says positive, so we use the positive value. If my first number is x, and x equals 11, then my first number is 11. If my second number is x plus 1, so 11 plus 1, my second number is 12. All right, question. There are some more challenging ones on the notes. So let's just kind of reason with it. Or maybe I'll tell you for your practice, since that's the one that you have to do work on. So if you get to problems like number 3 or number 5, where there's just more like words going on, here's how you would do that. It's still the same process. So like look at number 5 on your practice. All right, the length of a rectangle. I'm going to draw a rectangle in. Is 4 meters less than twice its width. All right, so we need to translate this into algebra. So the length equals 4 meters less than. Good. How did you know that it goes like on the other side? All right, remember we said like than is like a switch word. All right, so it's 4 meters less than, yeah, less than means subtract. But since it's than, we put it this way, right? We're taking it away from something else. All right, and it's less than twice its width. So twice its width, what operation would that be? 2x or 2w. We could do 2w because we're talking about the width. All right, does that make sense how we came up with that?
Yeah.
4 meters less than twice its width. So I'm going to put that right here. And the area of the rectangle is 70. Does it tell me anything about what the width is? Like any details about the width? So the width is just an unknown. When something's unknown, we usually label it with a variable. We can label it as W. We can label it as X if we want. Make this X or 2x minus 4. All right, but that's how we set it up. And since the area is 70 and area is base times height, put things in the right spot. All right, I'll let you guys continue solving from here, but just showing you how we set things up. All right, I want you to look at other ones from your practice. We'll talk about how you set them up. Any questions on number 5? All right. So like other ones on your practice, like number 7, the area of the shaded region is 103 square feet. What are the dimensions of the inside rectangle? So that one's, we're talking about the area is the shaded region only, so minus that clear space. That means that we had to figure out the area of the outside rectangle and subtract the inside rectangle. All right, so that's like 2 areas that you're finding, and then just subtracting them from each other. All right, but it's asking for the dimensions of the inside rectangle, so that's kind of like a longer problem. So here's how you would set this one up. So area equals base times height. Area is 103. And like I said, we have to take the area of this big one. So the dimensions of the big one are what? All right, so that's the dimensions of the big one. But then we also have to subtract that smaller rectangle. So we're not gonna have two separate problems. It needs to be all the same problem. But we need to subtract the area of the smaller rectangle. What are the dimensions of the smaller rectangle? Good. I'm gonna write it this way because I know when you distribute for the next part, you have to keep the negative with the 2x. And that's easier than keeping it with the x minus 1. All right, but that's how you set it up. So you would have to FOIL this out, distribute this, and then do the subtraction. And then you'll get something nice. So like, let's keep going with this one. When I FOIL this out, what are the first terms multiplied together give me? 3x times x. Good. The outer numbers, so 3x times 6. Good. Inner numbers. Good. And last numbers, negative 2 times 6 is negative 12. All right, let's distribute this over here. And remember, it's a negative 2x that we're multiplying by both. So what's negative 2x times x? Negative 2x. Good. And then negative 2x times negative 1. Negative times a negative gives me a positive, because you have to keep it as negative 2x times negative 1. All right, I know it's like longer, but that's how you set it up. All right, from here you would combine like terms, and then you get that nice quadratic function that you're used to seeing. So I helped you set it up, keep solving from there. Let me see if there's any other ones that I should help you set up. Question number 7. All right, so looking at number 10. So 10 says find two positive, even consecutive integers such that the square of the smaller integer is 10 more than the larger integer. All right, so again, a lot of words, just break it down so it makes sense. So I need to, it's a consecutive even integers. So that's like where it goes up by 2 each time, right? So my first number is going to be n or x. My second number is going to be n plus 2. So it goes up by 2 if it's consecutive, even, or odd. And it says such that the square of the smaller number, so if I take the square of the smaller number, so like n squared, is, so is means equals 10 more than, what's more than mean? Good. 10 more than the larger number. So the larger number we said is n plus 2. All right, everyone see how we just like translated it? All right, you just have to translate it into what it's asking for. If you have trouble with that, let me know. I can tell you, I don't know what the test looks like yet, but if it's hard problems like this, we'll spend more time on it than one day. All right, but then you would rearrange this so that it looks like the correct format. All right, so I would probably move everything to the left side so that that n squared stays positive. So I would first combine like terms. So 10 plus 2 is 12 plus n. And then I would keep moving things to the left. So I would subtract 12 from each side, and I would also subtract n from each side. And then on the left side, I have n squared minus n minus 12 equals 0. So that cancels out. Does that make sense? Anyone confused on what I did here? All right, I'll let you keep solving it from there. And that's all we have time for. Mondays are short days, so we won't have a whole lot more time, but if you can just get the gist of like how you just need to set up problems and use what you already know to solve it, then you'll